do not live on a spinning ball covered in water. Centrifugal force is the opposite to what you think. Water doesn't stick to spinning objects, especially one that curves in every direction. It doesn't matter how you spin water, the centrifugal force will push it away. I mean, it's basic science. How do you think a washing machine removes the water from your clothes?
Okay, this right here is inverted physics. There's the residual curve of the planet right there. The water is doing that on a flat plane here. Now, when you use the same kind of measurements, but on a different scale, you're going to have to slow this down to probably just a fraction of just a movement, and you'd barely see that water doing anything. Just like the tennis ball. If you fling it really, really fast, obviously, relative to the scale, everything's going to be flung off. You'd have to spin Earth probably 50,000 miles per hour instead of 1,000 miles per hour. Actually, I'd say 60, just round it up to about a minute or 60 minutes, or even 60 seconds. We'll just say 60,000 RPMs instead of 1 RPM. What's revolution per day, RPD. Then all the water be flung off everywhere, out into space or the atmosphere.
Find an equilibrium. When they're at rest, the surface is completely flat. It's time to realize the math ain't mathing and the science ain't sciencing. You can't even make it make sense.
Makes perfect
You're not
sense.
a random mutated monkey man living on an accidental rocket ball, so follow and bind your mind to find out where you really live.
Accidental monkey man, all that stuff. Now he's just mixing crazy shit up. He's basically saying if you don't agree with that, then you have to believe all this. And he's saying it's flat. Perspective is everything. If you're thinking inside the box, you're going to look and see a flat box. But if you're outside the box, you're going to see that it's pied. Okay, so I'm going to make a point here. Okay? Just going to make a point. Let's try to cover this up. All right? Now I'm going to spin it relative to how it's probably spinning. Really slow. Now you see, it's adhering to it. That water is adhering all over it due to gravity and adhesion because it has nowhere else to go except for there. It can't just float up into space. So this little model is sitting on the flat ground, which is the Earth, which is way bigger. So it's all going to get pulled down at any mass. It's going to get pulled straight onto the concrete. Now, the ocean is very thin compared to the rest of the planet. I mean, it might be 6, 7, 8 miles deep, and as deepest, the Marianas Trench is like 6 miles deep. But that's basically just a thin film. That's all it is. It's just a thin film, kind of like this little film here. Because on this scale, even the highest mountains to the lowest range in the ocean, it still equals a flat surface. Then if I wanted to zoom in with an electron microscope, I'm going to see this smooth surface here that I'm touching with my fingers is very, very, very rigid. And that's what helps the water adhere to the globe here on a small scale. So scaling is everything. So in that aspect, you can consider the flatness of it and the shape of it are actually two different things. Because of the malleability of the water, it's going to actually have a flatness to it in this shape of it, but it's still a closed system. And because we have a moon, it's actually shaped like an egg. An egg, menstrual cycles, an ovary, an ovum. It's an oval. Yeah, it's flat and elongated somewhat, but it's still spherical in nature because it's three-dimensional pie. So everyone's right and everyone's wrong unless they specify exactly what they're talking about. So it's basically all about specification. So we have Mother Earth, and Earth has girth, and that girth birth from the birth, which is the waters, from the waters. Birth is where the land meets the water. Birth is when the waters bring forth life.